Yes, Shahid, am I audible to you?
Yes, ma'am.
All right. So in the last class, which we had on last Wednesday, right, we had discussed Coulomb's law. So the basic points of Coulomb's law we had discussed, and questions also from Coulomb's law we had finished. So today we have to start with equilibrium of charges, which is also part of your Coulomb's law. So these questions we did. I hope these questions are clear to you. So yes, equilibrium of charges. See, when we are talking about equilibrium of charges, just few things that we need to discuss before starting it. See, when we are discussing about equilibrium of charged particles, so in equilibrium state, net force on the particles becomes zero. Whenever we are talking about equilibrium, the net force on the particles becomes zero. So electric force, net electric force everywhere is zero. And remember, under the action of Coulomb force, when only Coulomb force is acting, your we have two conditions apart from net force is equal to zero. Did you give the exam yesterday, Shahid, the test you had?
Yes, ma'am.
So there you must have seen a question, discuss the conditions of stable and unstable equilibrium, right? So when we are talking about net force as zero, it's not necessary that your particles are under stable equilibrium only. That's a different thing. Stable and unstable equilibrium, this we relate it with potential energy, as we had seen in electric potential and capacitance also. That stable and unstable equilibrium comes. Now, how to identify whether our system is in stable equilibrium? When I say system, see, there are two things. One is system, second is charges. Charge or the particle. Charges or the particles. Look here. When I say a particular charge is in stable equilibrium, whenever I'm saying a particular charge, so it's like, suppose you are having, let's say, Q, this is Q1, here you have small q, here you have Q2. There are three charges present in your system, right? Three charges present means three particles are present in your system. So when there can be two terms in your equation, in your question. One question can be discuss the condition or calculate the force on that particular charge when Q is in equilibrium or when Q2 is in equilibrium. So in those cases, you just have to check whether this particular particle, this particular charge is in equilibrium or not. Suppose I'm talking about, let's say, Q. So I have to check net force on small q is zero or not. And when we are talking about charges equilibrium, this was system equilibrium, and we are talking about charges equilibrium or a particular particles equilibrium. So in that case, what happens? See, what I have to check is, first I have to check this. This is the first step. I have to check whether the net force is zero or not. Suppose, let's say, here also some force was acting, here also some force F1, F2, they were acting and they cancelled each other. Net force on charge Q is zero. So that means this is the case of equilibrium. Equilibrium has been achieved. Now, second question is to find whether this is stable equilibrium or this is unstable equilibrium. So in that case, what will you check? When we are checking whether this charge is in equilibrium, whether this charge, we are just talking about the particular particle, not any other charge, just this. So you will disturb its position. Suppose you have changed its position and you have brought it here. If by the action of forces, this charge is able to return to its actual state, whatever it was its initial state, then we say this is the condition of stable equilibrium. Suppose on disturbance, I have disturbed the charge's original position and I have kept it here. Suppose this distance. Now, because of the action of forces, let's say all the forces are pushing it towards the opposite side, right? So the charge is drifting away towards the left side and it's not coming to its mean position. then that is the condition of unstable equilibrium. In the class also, I have told you that remember like this. See, if I take a ball and I drop it from here, if I push a ball will go up, it will come down automatically. Even if I push it on other side, ball will go up, it will come back to its original position. In whichever cases, ball will come to its mean position. This is its mean position. So it is equilibrium and this is stable equilibrium. This condition is stable equilibrium, where the body is returning to its mean position or the original position. Now coming to this, suppose I put the ball here and I move it. The ball, it will roll and it will stay here. The ball won't return to its original position, that is the top of the bowl, right? This ball also I have thrown it. It will go on this side and it will stay here. So mean position was this. The mean position has not been achieved by the ball on this bowl. So this is a condition of unstable equilibrium. So similarly here also, if you are disturbing the charges, what usually happens is, suppose both the charges are positive, they are repelling, it will move to its original position. Or it can happen in just that is case dependent. It is not fixed. You will see different cases. From there you will analyze whether the four conditions are of stable or unstable equilibrium. But this was the second one. This was when the charges or the particles were at equilibrium, right? You also have cases where your entire system is in equilibrium. This first case. When do we call the system under complete equilibrium? See, when I say system is in equilibrium, read the questions carefully whenever they are given to you. Particles in equilibrium. Secondly, charges are in equilibrium. When you have the charges under equilibrium, this was the case. You just take that particular charge, you disturb it, you check whether it's equilibrium, unstable or stable. If the entire system it is talking about, then you have to consider this charge 1, this charge 2, and this charge 3. All the 3 charges you have to check. Suppose you have checked this is the net force is 0 on this charge. You have checked this charge, net force is 0 on this charge. You have checked the net force is non-zero. Suppose, for example, the net force is non-zero over here. That means your system is not in equilibrium, even though the rest of the 2 charges were in equilibrium. Fine. So you have to identify, whenever system is given, you have to check for all the 3 charges, first, second, and third. You have to disturb each charge and check whether they are in stable or unstable equilibrium. This is how you have to identify when the entire system is under equilibrium. This is how you find. Fine. And these questions also you get if the charges are present, find out the point where net force is 0, net electric field is 0. That is the neutral point which you have to identify. Even if a third charge is placed, you have to find out the position of the third charge. So these things are mentioned. Apart from it, one thing we discussed in the theory class also, that if your system is symmetrical, like if a triangle is given, let me show you. For example, if a triangle is given, this question we'll do just 5 minutes. Suppose a triangle is given to you. This is plus Q charge. 3 charges are present. And let's say the side is symmetrical. If this charge wasn't present at the center, suppose this was the question given to you, and at the center O, I was asking you the net force. What would be the net force, Shahid?
0.
0, right? Net force would be 0. But suppose if I bring a charge plus Q over here, fine, I have brought a charge plus Q over here. So see, in such cases, what will happen? Now your net force won't be 0. When you have symmetrical system, under your symmetrical system, the net force becomes 0. That is fine. But when we are talking about the net, when you are putting up a charge over here, Now it won't be 0 because see, there would be some separation of the charge from the center. That is, at the centroid, this is kept. So if now you are asked what is the value of this charge so that the entire system is under equilibrium, then your value will come out to be minus q by root 3. No need to remember this, you can solve it, but at least for triangle and square you can remember. Even if you do not remember, that's okay, you can anytime calculate it. How will you calculate it? For each charge you will calculate it as 0, right? For this charge, you will calculate the force, that will be K Q small q by the centroid. I'm taking the centroid as R, let's say, R square. Then you will calculate this, then you will calculate this, right? So entire the value will come out to be minus q by root 3. How will you calculate? Whenever you have such types of questions where this system is given and one charge is mentioned, you won't calculate just by this q, otherwise your answer will not come. How will you get minus q in your answer? What you do in such cases, take any one charge. Let's say I have picked up this charge. Fine, just pick up one charge and calculate the forces due to this charge, right? Calculate all the forces due to this charge. For example, one will be this, one will be k q square by a square, right? Another one will also be plus k q square by a square, like this. And one will be see, this is a by root 3. Whenever we have the centroid of the triangle. So I'm just taking it as R. So just we can understand how to solve this. So this is the force due to this. Then equate it with the force due to this charge. That is K Q Q by R. A root 3 will come here. So again, a square will get cancelled. Ultimately, you will be left with this. This is how you solve it. Whenever you are having questions on equilibrium, don't just take this charge. Don't just take because of this capital Q. Otherwise, in your answer, you'll just get your answer as 3kq square by a square. You'll be confused how to solve it further. So this is how, just remember it for one for triangle, you should remember, and one for rectangle, just remember, square, just remember it. This is a square, a side is present, all the 4 charges are present. If you are asked this question and at the center of square you are asked, so what will be your answer? Net force?
0.
0. But if charge Q is present, then your answer is not 0. Again, how will you solve this? Take any of the corner charges. Take this. Take this. Then force on this. What are the forces on this? Because of this particular charge, because of this particular charge, because of this particular charge, equated with the force due to the capital Q which you are finding. When you will solve this, your charge will be minus Q root 2 plus 1 divided by minus Q root 2 plus 1 divided by 4. Why root will come? Root will come because of the separation between the diagonals. Root 2 a by root 2, which we get, no? Because of that only we have it. So when you will solve it, you will see this. So just remember for these two only. Rest, any type of question can come that has to be dealt in this manner. Just note it down. We'll see some questions also, some other numericals from this. Just note down this part.
I'm finished.
One question let us do based on this square, then we'll come to this string question that has been missed here. See, question says that you have to find out the question. So for a system figure is given for a system shown in figure, just a second. This is the net charge on small q. The refined q find capital Q for which the resultant force on small q is 0, for which the resultant force on this is 0. Let me show you the figure. See, a square is given to you. This is small q charge. Here you have the small q charge. Capital Q is there. Capital Q is there. These are negative. These are positive charges. So A, B, C, D, you can take it. Side is A for all the squares. This is the squares are side A and AA is the side of the square. Now we have to find, see, for a system shown, we have to find where the resultant force on small q is 0. Take any of the charges of it. First, we'll just see this figure. See, if we are talking, let's talk about this charge, this particular charge Q. Let me mark these. This is A, this is B, this is C, this is D. Now we have to first check what are the directions of forces due to this. So tell me, let's consider this charge. At D point, we are considering this charge. Now you have to tell Shahid, if because of A, this point, what will be the direction of force on this Q?
Towards negative.
Towards the negative charge, means dA, right? Like this. Yes. Because this is getting attracted. So this would move towards it. So let's say this is FA. Fine. And for due to this C point?
DC.
DC, right. Negative charge will be attracting it. So this is FC. And due to this point B?
Away
from the diagonal. That is BD. Away from this, because these are positive charges. So this gets repelled. So this is force due to B. These are the forces that we have. Now, net force, it means all the forces should balance each other. Now, if you remember through parallelogram, the parallelogram law, you can identify that the resultant of these forces is the only way which can balance this, right? Because of parallelogram, this would be the resultant of these two. And then this resultant would be balancing this, then only the net force can be 0. Because we know the final answer that net force has to be 0. Because this is given you under equilibrium. So if it is given that under equilibrium, you have to find out. So obviously, you have to keep in mind that net force is 0. See, regarding the magnitude of FA, if we talk about the magnitudes of these, FA, look, the magnitude, this would be K, small q, capital Q divided by A square. Same thing will occur for this also. If we are talking about FC, this is also the same thing, no? K, small q capital Q divided by a square. So both are same. I am writing it as f right now, just for the calculation. See, if two parallelogram, two vectors are representing the sides of parallelogram and the resultant is given by their diagonal. This is the statement of parallelograms law. So angle that is formed between FA and FC, what is the theta's value that you will take? In parallelogram law, we have no a square plus b square plus 2ab cos theta. These are two forces for you. One force, second force.
The angle between the resultant and
The angle between the resultant and the vector, this you will take. See, what am I asking is, when you have two forces, right now you are having two forces. This is one force, FA. This is another force, that is FC. We know their magnitudes, KQ by A square. What is their resultant? We have to find out the resultant's magnitude. So for finding out the resultant's magnitude, we have to find out their angle, because what is the formula? A square plus B square plus 2AB cos theta under root. This is the formula of finding the resultant's magnitude through parallelogram law.
yes, ma'am.
So what is the value? See, one vector is A. Which vector is A here?
FA.
FA, you can take any of it. B will become FC. What is this? This is I'm asking.
Angle between two vectors,
So that is
90 degrees.
90 degrees, right? See, these are squares and we know the vertices of the squares, they subtend an angle of 90 degree. So directly we know this is 90 degree, cos 90, this entire term will be 0. So when this entire term becomes 0, our resultant, our first force, F1, let's say this force is F1, this will become under root FA square plus FC square. That is, let's write their magnitudes as same. Let's write it as F square only, because we know both the magnitudes are same. That becomes 2F square under root, which is F root 2. This is the value of it. And we can substitute the value of F also as K capital Q small q divided by A square. This is one thing. It means this part we have obtained. What is this? FB. Can you tell me what is the value of FB?
AQ square by root 3A.
Root 3. See, this is one side A, this is one side A.
Root 2A.
Root 2A, right. Say under root A square plus A square will be left with you. So that is root 2A. And when we are taking half of diagonal, you should remember this because this gets involved a lot in your questions. When you have the complete diagonal, that is root 2A. When you're just having the half of the diagonal, then we take it as A by root. When after rationalization, so this gets used. But since we are not calculating it at the center, that's why A by root 2 won't be used. We'll have the entire root 2A. So yes, right, FB will become KQ square divided by root 2A whole square. Now, this FB is what? This is the force here. And this is the resultant force that has been obtained. If the question is saying small q is under equilibrium, it means net force is 0, means both these forces are balancing each other. They are cancelling out each other. So if they are cancelling each other, FB will be equal to the resultant force F1. Or let me write it as F resultant only so that it doesn't become confusing. This is F resultant, means resultant between both the vectors. So one we had obtained as root 2F. F was K small q capital Q divided by A square. And what is the other force that we have obtained? K Q square A square, and this root 2 into root 2 will become 2, right? So A square gets cancelled. One q with this q gets cancelled, k gets cancelled. What is the value of small q we are obtaining? See, 2 root 2 q. But do not write this as the final answer, because in your all the 4 options, no, one option will be this, which will be wrong. Why? One option will be with a negative sign, which will be correct, because the magnitude of this charge is negative. So when we are writing the final answer, no, if in your option minus sign is not given, then definitely 2 root 2q. But if it is given, you will choose minus sign. Clear? This is how we solve the questions of equilibrium. This is
Yes.
clear, Shayad?
Yes, ma'am.
Okay, note this down. Then we'll do some suspension questions. Shahid completed?
Yes, ma'am.
Fine. One question, let's see. This is related with your mechanical properties of fluids. You had a lesson in class 11. See, this says that two identically charged spheres, they are suspended by strings of equal length. It says that the strings make an angle of 30 degrees with each other. They are suspended and it makes. Fine. When suspended in liquid of density 0.8 gram per centimeter cube, the angle remains same. What is dielectric constant of liquid? Density of sphere is given to you as 1.6 gram per centimeter cube. See what all things we have. We have the density of the sphere. We have the density of the liquid. This entire setup, this is suspended into liquid. Fine. So we have the density of the sphere. We have density of the liquid. The angle that the strings are making is 30 degrees. And in the figure, if you look, this angle, this is half, right? If you look here, this angle is 15 degrees. So that's why this angle is also 15 degrees. Now, what all forces will come here? One thing will be, there will be this force of tension. Tension will come here because the strings are present. So one force that definitely comes is force of tension. Tension is there. So is it directly possible to solve tension like this? Force is there in x-axis, mg is also there in y-axis, but tension isn't present particularly in one of the axes. So whenever you have such forces which are not coming under axis, you have to resolve them along x-axis and y-axis. So this is, okay, tell me, Shahid, you tell me, if this force is tension, which will be this force over here? What will be the force here?
Cos 15.
Cos theta, right? This becomes T cos 15 degree and this will be T sin degree. Yes, this will be T sin theta, that is T cos theta. Now see, let's see what all things are balancing each other. T sin theta is equal to this force, electrostatic force, and T cos theta is equal to mg. So this is one equation. This is second equation for you. If you take their ratio, T sin theta divided by T cos theta becomes force divided by mg. Tension gets cancelled. Sin theta by cos theta is tan theta, and your theta is actually 15 degree. So tan 15 degree becomes equal to force divided by mg. This is what we have. But see, if the system was not dipped under any solution, this would have been your answer. From this, you can calculate the value of the dielectric constant K or epsilon naught value, whichever value you want to find out. But the problem with this question is that your gravity is changing. You must have heard, you must have studied this lesson, no, mechanical properties of fluids. So there, when you apply the buoyancy's principle and all, the gravity also changes. So effective gravity will not be exactly 9.8. Otherwise, what is the value of gravity that we take? 9.8 meter per second square, or if you roughly estimated, this is 10 meter per second square. So this value changes. So effective value, whenever you are having any system that is suspended in some solution, in some liquid, the formula of the effective gravity, this becomes mg, means the actual gravity. Let me write the general formula first. The gravity, the actual gravity that is present in air, this is the gravity in air. Acceleration due to gravity in air, 9.8 meter per second square, multiplied by 1 minus density of the liquid divided by the density of the solid. Sigma I represented for the liquid and the rho for the solid, but I have also mentioned L and S. This is how we write it. I think you must have heard of this already. Derivation is also there in your syllabus of class 11. But right now, no need to go by the derivation. Just remember the formula. Whenever your entire apparatus is dipped in any solution, and otherwise also densities were given to you. It could have happened that the densities values are not given in terms, instead of those values, you particularly have sigma or rho or any other variable. So liquid by the solid, this is the case. So now your entire formula will be the same with the value that your effective gravity will be this. This is your effective gravity. So now you just have to put in the values of the force. Tan 15 degree will be equal to F, that is the force, kq square by mg, kq square by a square, whatever is the separation between them that you take, divided by mg 1 minus sigma liquid by density of the solid. This is how you have to take in. Fine. And epsilon naught, you do not put it as epsilon naught. Whenever you are substituting it, put it as epsilon and calculate the values. Do not take the force, take it as kq square by a square, we take it, no. K, the value of K, this will become epsilon, which we take it as kq square by A. Instead of writing this whole term, this becomes epsilon. Fine, this is how we solve it, and answer of epsilon is obtained. We do not put the value of epsilon naught. Note it down till here. Answer you can calculate later also. Right now also you can calculate, but first note down till here. One more thing, just one more thing, Shahid. See, here, no, when I'm talking about that epsilon naught, you will not put, not put this entire term, you'll just have the value of epsilon. See, how will you calculate? No, because you do not have the values of A also, the separation between the point masses you do not have. You just know your answer till here. So what we do, because the force is also new, the effective force that we put, no, the forces value that we are putting here, this force is actually force divided by epsilon r, epsilon for any medium. Remember this question, this formula also we had seen when we were discussing Coulomb's law, when a different medium is there, when apart from air, if you put it, remember this formula, Shahid?
Yes, ma'am.
Yes. So if you, when you will use this formula, so what will happen? Now, when you will put it, your tan 15 degree, this will become force divided by mg. This is your epsilon r or epsilon in any medium, 1 minus sigma liquid by rho solid. This is the formula that you have. And this entire apparatus, this term, this is the formula of force. This is equal to tan 50 degree. And what is the value of tan 50 degree that we have obtained? Value of tan 15 degree is F by mg. Right? Value of tan 50 degree, we have already equated it as F by mg. So here when you write it no, as F by mg, your mg will also get cancelled. Force, and mg, these will get cancelled. So your epsilon, from here your epsilon r will be equal to 1 by sigma liquid by sigma rho solid. Now you have the values of sigma liquid and sigma solid, so your answer will come in just 1 or 2 steps. See, 0.8 divided by 1.6. This is 0.8 and this is 1.6. So just check and let me know what is the value of epsilon that you're getting, the dielectric for this particular medium.
Which is 0.8?
See, 0.8 is liquid and 1.6 is for sphere. Note down the question, note down this from here. Let me know when you're done. And do let me know the final answer also once you have written.
I'm getting 2.
Yes, right. Answer will be 2. Done, Shahid?
Yes, ma'am.
Okay. See, now the next topic that we have, we'll be starting with electric field. But one or two things, I think, some points, if they are left, I'll just cross-check from this. Most of the things we have covered, from Coulomb's law, from equilibrium of charges. Basically, this was superposition principle, application of it. So next class, I think we'll have it on Wednesday only, no? When are you comfortable? Last Wednesday, we couldn't have the class, right? So I think Wednesday only we'll have the class, no, after
Yes,
our regular class. Okay. One more thing, Shahid, I wanted to discuss. I had received your syllabus. Your exam is on 18th, no?
yes, ma'am.
So 18th means next Sunday.
Yes.
So see, Shahid, today you have one class. I think 3:30 your class was